So we're gonna focus on, talking a little bit about using a proxy. We won't actually go into configuring Proxy SQL, because I think that's a topic for another webinar by itself. We'll also give a high-level comparison of Galera Cluster versus Amazon Web Services relational database service for MySQL and MariaDB server. And we'll also talk to you a little bit about Galera Cluster versus Amazon Web Services RDS Aurora for MySQL to be more accurate. Aurora also exists for Postgres, and we will not cover that. So a little bit about Codership. Codership has been around now for over 12 years. The the company is basically known is the maker of Galera Cluster, and I always say we're the developers and experts of Galera Cluster. It's three engineering founders: Seppo, Timu, Alex. There's a full-on services business model. It basically Codership produces 100% open source software, so there is no closed source anything really. It's got very wide used, well-tested software in different kinds of applications that vary from e-commerce to betting, telco, banking, travel, education. Basically, anyone who decides that the application cannot tolerate any downtime or data loss or lost transactions, with ease of use, of course, would most likely end up using Galera Cluster. And I think that's generally quite handy. So to get everyone on the same page, we have to talk about replication available in MySQL. And there is also replication available outside of MySQL. And that is actually what Amazon's products are built on. So RDS for MySQL is built on Linux block replication, and Aurora is built on physical replication with the replication layer of MySQL more or less torn out. However, we have to talk about MySQL replication because Galera offers one of the three types. Asynchronous replication is the normal type of replication that most MySQL users are used to, in where you insert from your application into a primary node, and it may get transmitted to a secondary node. There may be delays, there may not be. If the master goes away, there's a good chance that there might be some data loss. Typically, you'd also need to have a framework to handle automatic failovers, which is why semi-synchronous replication sort of becomes more popular, because when you insert, at least one of the secondaries will receive the transaction. So it's not just the primary. So if you happen to lose the primary, all is still well, but you of course still need a failover framework. Galera is virtually synchronous, and every insert basically writes to all the nodes when it's ready to commit. So you don't need a framework. The ability to handle failover and failure is built in. So there's no such thing as a failover. When you have a minimum of 3 Galera cluster nodes and one goes away, the cluster is still healthy and the two continue running. So Galera cluster is true multi-master application. To your application, it looks like one large database with multiple entry points. Transactions are processed locally until commit time, then replicated across nodes through the entire cluster. So naturally, if you have a 3-node cluster, it replicates 3 times when it's time to do that. When you have a 5-node cluster, it has to do it 5 times. So keep in mind that the more nodes you grow, the the more in terms of latency there will be in terms of commit time. It is also, of course, virtually synchronous, so that each transaction is immediately replicated on all nodes at commit time, so that there are no such thing as a stale secondary. And being multi-master, you can read from and write to any node. It also has automatic transaction conflict detection. Now, of course, in scenarios where you have hot rows, or you have 5, 7 nodes, or 9 nodes, you may want to throw a proxy in front of Galera as well, so that you don't write to all 9 nodes. You read from all of them, but you maybe write to 3 or 5. Then there's also, of course, replication where, it's basically a copy of the entire data set. It's on all nodes. So if you have 100 gigabyte database in MySQL 1, MySQL 2, and MySQL 3, it's the exact same 100 gigabyte database across three. So you actually have the exact same information across multiple nodes. And of course, new nodes can join automatically. It does not need to be bootstrapped in the cluster, so to speak. It is InnoDB only, and it has data consistency protection so that you never have to read stale data, and it also prevents unsafe data modifications. And it can also have WAN support, so wide area networks, which is basically the cloud, right? So you can have nodes on different continents. It is end-to-end encrypted, and it's also got optimized communication with least latency available. So this really means in the Amazon context, you could store your data in Singapore, Sydney, London, and this is all hunky dory with Galera. So Galera is generally very highly scalable. You can add delete nodes on the fly, and it's uses a quorum-based failure handling. So one, it obviously has no single point of failure, but following the quorum-based methodology, generally you'd have two. You never have an even number of nodes. You'd have odd number of nodes, which is why we always talk in multiples of 3, 5, 7, 9. It uses optimistic concurrency control, which I explained earlier as to how it processes and then puts the data, replicates the data upon commit time. And of course, all your nodes are equal uh, across your entire topology. And it's a core feature of the product, by the design. It's not something that has been tacked on. It's not a framework. You don't actually need to designate single nodes for writes and the rest for reads. Uh, it's just built into the system, and it also has the ability to have parallel replication and/or parallel apply, which is where you can have multiple slave applier threads on the row level, and it applies in parallel with proper commit order to ensure that you can recover if need be. Galera is also optimized for the cloud. So the packet network protocol is great because it's exchanged over the WAN at transaction commit time. Uh, it's also interesting to note that if you have three nodes in some part of the US, three nodes in London, and three nodes in Singapore, and you write to the uh, nodes in the US, for example, it would not write 9 times across your topology. You would only have to write 5 times because it actually writes to London once, and then that node replicates the data, writes Singapore once, and that node replicates the data too. So that's what we mean by topology-aware replication, where each transaction is really sent to the data center only once. Naturally, it can detect and automatically evict unreliable nodes. So if you have a flappy network, node failure, you can't rejoin without manual intervention. In the unlikely event that you have split brain, it will automatically recover this and manage it. And of course, there is also the ability to have traffic encryption, which is really important in the cloud. So everything can be SSL encrypted. So let's dive right into what we're here to talk to you about, which is the Amazon ideas around regions and availability zones. A region is a collection of zones, and it's a data center location containing multiple availability zones. And availability zone is basically, let's say you have 3 availability zones as shown in this diagram, which I've taken from Amazon. It's basically one region having 3 availability zones, and each availability zone is isolated from failures from other availability zones. So it's an isolated location within a region, and it's also got very low latency network connectivity to other zones in the same region. And the reason why this is important is because RDS has this option called Multi AZ. And Multi AZ provides enhanced durability because it implements synchronous data replication, not via MySQL, but via Linux's DRBD, Distributed Replication Block Device, which is block level replication across availability zones. So naturally, you do have increased availability because DRBD does support automatic failover, but the large databases tend to, be slow when there's a failover. And you also have performance degradation compared to when you just use RDS without multi AZ. Um, and in past benchmarks, people have seen worst case scenarios around 50-60% of performance degradation compared to regular RDS. This has not been benchmarked recently, so this is probably something folk can do as well if they're interested. And the other thing about RDS Multi AZ is it doesn't give you another usable read replica. And this means you are effectively paying money just to have a passive failover target. And this is you're sort of, it's not maybe good for the environment. It's probably also not very good for your pocket. So why would you run Galera Cluster in the AWS EC2 cloud? It's a very simple why, really. It's largely because Galera Cluster itself is not available on Amazon Web Services as a service. You can't just log in and say, hey, I'd like to launch Galera Cluster. For regular MySQL or MariaDB, you obviously tend to get a lot more configurability out of EC2 because it is basically just Linux. So you can configure the file system, you can configure the database. You have many options you can configure if you're running it in EC2 yourself, because you really are just paying for Linux instances with Amazon as well. And you may occasionally have to pay a little more than a standard RDS instance. And when I say standard RDS instance here, amongst price comparisons, it's possible that the Aurora is quite interestingly priced, maybe to get migrations over. There are, of course, other considerations, and locations would naturally be a good consideration, as you want to pick to be close to your data center. And Amazon has varying availability zones in regions. Some have previously had maybe 2. Aurora needs a minimum of 3 to work. Some have 5, and so forth. The AWS cloud today operates 66 availability zones in 21 geographic regions around the world. And this is steadily growing because it used to be that in 2018 it was 18 geographic regions with 55 availability zones, and the year before that in 17 it was 16 geographic regions in 44 availability zones. So you can see that Amazon is really spreading their data centers out there. Cost across data centers also vary. So things in Sao Paulo and Singapore cost more. Singapore, for one, can totally gather costs more, largely because land is scarce. You may be able to get much better deals in Northern Virginia or and so forth. The other thing you want to think about is SLAs. It says it's got 99.95% in a calendar month, and if it's anything less than, you'll get a 10% service credit. 99.95% in a calendar month means that you can potentially be down for 21.56 minutes of downtime every month. Now, the reality of this is that 99.95% in a calendar month does not include the fact that it also has a situation where you can have up to 30 minutes of elevated I/O when Amazon does maintenance tasks on your instances. So degraded performance could be anywhere, could be up to even 142 minutes a month, which is a little over 2 hours every month. So you're really getting 99.65% in a calendar month. So this degraded performance may occur when your application needs it most. You don't control this, obviously, at which point you obviously need to have multiple replicas. So support, there are obviously very active forums for Amazon. And you can, of course, pay for support. I believe it starts at around $49. It goes on to $100, and for more usage basis and so forth. And then when it comes to management, it's generally you managing it yourself. And if you're enterprise, it starts at something like 15,000 and goes on. There are obviously other considerations as well, like backups. Amazon does automated backups with point-in-time recovery, and also has full daily snapshots with a backup window. So this backup window is something where you'd have the elevated I/O. However, if you use multi AZ, the backup is taken from the standby, so your main server never actually gets hit in terms of performance for the backup. One thing you want to probably configure if you end up using RDS is the backup retention default is quite low. You probably want to increase it. And when it comes to monitoring, you obviously have CloudWatch, and then there are obviously third-party tools that are available that you can pay for through the cloud. But this is not your typical roll your own Isinga or Nagios and so forth. Then we need to talk a little bit about costs. So the minimum sort of thing you'd want to run a production database on is probably use the RDS M5, which is the DB M5 extra large, 4 virtual CPU, 16 gigabytes of RAM, and that comes up to 17 cents per hour and 68.4 cents per hour for multi-AZ. You can get discounts if you prepay or you sign a 1-year or 3-year contract and so forth. Then there's also the EC2 instance, which you can roughly compare because after all, RDS is just managed on top of EC2. The M5 extra large, again, similar configuration with the DB M5 extra large, 19.2 cents. So one could surmise that you are actually maybe getting more for less money with the DB M5 extra large, which obviously means that there's some kind of subsidy going on for you to use it. However, we can't use that as a fair comparison because Aurora is a more memory optimized, and it's probably also worth mentioning on a tangent. You get the 3,500 megabits per second dedicated EBS bandwidth as well as 10 gigabytes network bandwidth. Anyway, we go back to Aurora. It's more memory optimized, and you need the R5 instances as well, which is again 2 vCPUs and 16 gigabytes of RAM. And this is where it starts getting interesting, because if you take a memory optimized instance, EC2 drops down to 12.6 cents per hour. It's fairly reasonable. RDS is a neat 24 cents per hour, so you're no longer getting that subsidy. You are effectively paying nearly double of what an EC2 is. So you're now paying for that management, and it's 48 cents per hour for multi-AZ. Now remember what I said about multi-AZ is that you actually do have a second passive failover node, but you can't actually read and write to that like it is your secondary or slave. So you're effectively paying double the price and not getting the same effect of actually running replication. This is maybe a little odd. And then of course there's Aurora at 58 cents per hour. So by far the most expensive available. So if you do some mathematics, you could probably run even 4 EC2 instances. That's 3 Galera Cluster, 1 Proxy SQL, and still probably come out ahead of Aurora if need be. So the monthly running cost of 3 EC2 R5 large instances with 100 gigabytes of storage, yes, you've got to pay for storage. And no, I have not included network costs as well. Network costs is something you also have to pay close attention to because that's where you can be sort of whacked and or surprised, especially when you're starting to send terabytes of data to maybe another region. There are fees associated with that, and I'm not drawing that up here in the cost table, but there is a good resource later for a cost table all the way at the end that Amazon provides for that you can use. Anyway, a minimum Galera cluster with no proxies or anything, $303 a month with 100 gigabytes of storage is what you should be expecting to pay, which is not too bad. If you happen to run 3 RDS DB-R5 large instances with 100 gigabyte of storage, so basically you are running it in mode of a master with 2 secondaries, you're looking at about $560. And running 1 RDS instance with multi-AZ, 374, so just 1 master and 1 passive failover target. So keep in mind that this is still more expensive than 3 EC2 R5 large instances. And then it comes down to the monthly cost of running 1 RDS Aurora DB-R5 large instance, again with 100 gigabytes of storage, $219.98. So that is a significant savings from 3-node Galera cluster. However, the 3-node roll-your-own Galera cluster is still, I'd say, cheaper than you running than you probably having to run 3 RDSs or even one RDS with multi AZ. So it just involves a little bit more configuration on your part. There's so many automation tools available out there. You can use Ansible or Puppet or Chef and roll your own deploy. But Aurora is obviously priced in such a way that it looks like you're getting a very good deal compared to anything else. And well, of course, you're getting a good deal because this is also a proprietary database, and it may be a good deal today. We don't know what happens tomorrow. Anyway, who runs and manages Galera Cluster and EC2 instance? Basically, you do. And of course, if you don't like to, run or manage your EC2 instance, you can contact your friendly Codership sales representative for managed service offerings. Running a Galera cluster in EC2 is actually not very different from running it in Linux, so you don't really need much beyond the usual setup. Where you run your Galera in AWS, today obviously it's EC2. Tomorrow it could be, in the marketplace, and you could launch EC2 instances. I don't know if that's a customer requirement of yours or not. When you actually want to do it, when you basically feel like you need virtually synchronous replication, node management, high availability, and it meets your requirements. So, hopefully we sold you on Galera earlier, failing which, there's always many resources and other just Galera cluster only topics that we talk about. You run Galera largely because of the features. And I'm gonna basically show you how to run it in AWS fairly quickly. So this is the Amazon console. This is quite common. And you'll notice that when I'm choosing to launch an Amazon machine image, it's actually basically out there telling me if you're going to launch a database instance, why don't you try RDS? Which is interesting. They're more or less telling you, hey, like maybe you don't want to use EC2, you want to just use, something managed for you. And it's true, it is easy, and it may be cheaper, but you may also end up in a situation where you're locked in. But before I go direct to the demo, I want to run through a few things. One is security groups. You need to open up a bunch of ports. We normally open up obviously SSH because gotta log into these machines. But open up MySQL port 3306. Galera requires a bunch of ports as well: 4444 for incremental state transfer, and 4568 for state snapshot transfers. And then when it comes to communications for Galera cluster communications, there 4567's TCP as well as UDP needs to be opened up. And this is the security group configuration that one would need. And because it's quite long, I've actually pre-saved this inside of Amazon's interface, so we won't be spending time entering this manually. Of course, you can run SE Linux, but in this demo, I'm going to turn it off. But if you are running SE Linux, it's just a bunch of SE manage port commands, basically putting every single port and then saying you're going to run the permissive MySQL DT. And it's similar for the firewall as well. So again, the firewall in Amazon Linux is actually disabled by default. So yeah, let's quickly run through this. So we're on the EC2 dashboard, which currently says that there are 0 running instances. So I'm going to do a launch instance. You have obviously got 2 types, the x86 as well as ARM. Do not run ARM because we don't provide packages for ARM. It's true that MariaDB Galera cluster does have ARM packages in the Debian distribution, but for all ease of use, let's go for x86-64. We're gonna launch the T2 micro, which is like kind of small, but really this is just a demo, so it doesn't really matter. I'm going to launch 3 instances together, and you can also launch this into an auto-scaling group that can also add instances for you. And we're not going to change anything else here. I'm just going to use the basic default 8 GB of storage per instance. I'm not going to add any tags. And when it comes to configuring the security group, I'm actually going to use an existing security group called Galera. And if you'll notice that the Galera security group already has what I talked about earlier with custom rules. I'm going to have to obviously still edit them to change the private IP addresses, but that will come in a moment. So yeah, okay. So let's just hit the review and launch. We've got some custom rules here, and we're going to hit the launch button. You can create a new key pair. I'm just going to choose one that I already have for this demo, and then I'm going to just hit launch instances. And it turns out that this should be fairly straightforward. It's going to initialize, and I made obviously a cheat sheet to copy and paste stuff into the console. So now, yeah, it's initializing, and we'll let it initialize for a bit, and I'll just talk to you, on the next topic, which is proxies. So, we have proxies like Proxy SQL, and this will obviously take another instance. But as I said, even if you ran 4 instances, it could be cheaper than doing an Aurora one node. It obviously, the reason why we talk about Proxy SQL and not just the other proxies like MaxScale as well is that it has native Galera cluster host group support, and it also can work with RDS and Aurora. So it is not just something that works with Galera cluster. And there are a bunch of good articles on Amazon's blogs to tell you how you can use Proxy SQL to do things like read-write splitting, how you could configure it to even do monitoring and so forth. It's quite handy. So let's see. So we've got some running instances here, and you'll note that every running instance has a public IP, which I will connect to, and it also has a private IP. The private IP is important because this is the one that we're gonna, make a note of here. So I'm gonna actually put all private IP addresses inside here. So we've got 35 in that one, and node 2 has 177, and 035, 177, and we've got 151. Okay, so and so I'm going to connect obviously to the public IP. So we're going to presume that that is node 1. I'm going to just move this a little over here because GoToWebinar also has this fairly annoying thing. So that's the first node I'm going to connect to. And I'm going to also connect to the second node. And the third node. Okay, so that was the maybe easy part. I'm gonna set and force 0 on everything to disable SE Linux. You probably don't want to do that in real life. But I'm doing it, as I told you, to save time. And just noticed a quick typo there. So these repositories are all fully public, and you could totally end up using them with ease. We totally support all of this, and I'm going to now install it, and then I'm going to we gotta make sure that That's the okay, so that's the other thing. So we're just gonna install that. So installing it across 3 nodes, and it's pulling it all down from Galera Cluster. Then, one thing we gotta do is we've gotta obviously grab the password for the initial node in a moment, because MySQL 5.7 saves it in the error logs. But before that, I'm going to configure the my.cnf a little bit, and all this is documented, by the way, in our documentation. So I'm just going to put this here. Which more or less just tells you what's in the cluster. And then I'm going to run a bootstrap. So I could just do a sudo mysqld bootstrap. So I can just do a sudo mysqld bootstrap, and this will officially start mysqld for me. But the way mysql is set is I need to also grep for the password, which happens to be this. Then I'm going to log into MySQL with said password, and I'm going to actually just alter the user to have a very simple password. The funny thing about this simple password is that because MySQL 5.7 also has the validate password plugin, you need to also have that available. So officially, I should be able to connect with this simple yet complex looking password. Ooh. And do something along the lines of show global status like wsrep. And you'll notice that I am actually running Galera Cluster, and the cluster size is currently 1. Now we have obviously got 2 other nodes that we can start up. So let's make sure that this also gets this configuration. And I'm going to also configure this node to include that as well. Now, in theory, I just need to do, so just make doubly sure I have 1 node there. Now I can just sudo system ctl start mysqld, and it's starting. but not quite finishing yet. So you don't have to bootstrap any other nodes, you just need to bootstrap one node. Ooh. So we have obviously got a little error here, systemctl status mysqld.service. Well, that was obviously not quite there. So mysqld is not starting at the moment. And let's take a look at the error logs real quick. So could not open state file for reading gra state.dat. Yes, okay. So there is obviously some Galera communication going on, but not quite the. So as you can tell, real life demo, real life problems. Even though if you run it without the demo, it actually more or less just works. So timed out 4, 5, 6, 7. So I'm just going to make doubly sure that all these are using the correct security groups as well. 117.254.58. Aha, well, that explains a lot. So now you can tell why it didn't work is because the security groups were incorrect. So we have got 117 as one well, actually this is no longer 117, is it? So I need to make doubly sure I've got the IPs correct as well. Don't worry. But so actually this is private IP is 35, which is good. So we've got 35, 177, and 151. Just make sure that it's a 35. Aha. Look at that. 35, 177, and 151. Okay, so we already know where there was a tiny error, so that's an easy fix. It's for one, it's trying to connect to something that doesn't exist to begin with. So we don't want this 117. We want it to be changed to 35. So 2 instances. So this is again not 117. pretty sure that that's 30. So yeah, basically I've just not read correctly. That's the the real problem here is this is also not 35, it is 30. So yeah, so minor mistakes in IP addresses can obviously cause some vague misery. So don't make those errors, and you will have less misery. Okay. Yep. So this one's going to be 0.35. This is a 30. And here we are at 177. And so error logs are great for these purposes. And again, we just want to make sure that this is 35. And this is back to 0. And we want to make sure the security groups are accurate. So we've got 30, 0, 35. So this is quite the manual process. You've got to replace everything that you've set, or you set it up manually. And then we've got 177. And 151. Okay. Now they can connect to each other as well. I'm going to make sure that we really do have a MySQLD bootstrapped. P. Okay, let's also now okay. So we're on another node now. And like magic, we're connecting to all of them, as you can see, once things were better. So we know that the cluster size is basically all the same. They are all connected to the same cluster. Look, we've created the database Galera. It's happening there. I'm going to use Galera, and I'm going to create a table test here. Then I'm going to use Galera here, and I'm going to insert into test a message. And I'm going to select star from test. That's not going to work because I've got to use Galera first. And it's there. So all is generally well, so to speak. Okay, so that was the demo of you having a live Galera cluster. Make sure you get the security groups right. Make sure you don't look at those IPs incorrectly. It is 12:46 a.m. for me, so that's why maybe I've looked at the IPs a little incorrectly. But yeah, basically that was you setting up a Galera cluster in typically less than 10 minutes. So Amazon RDS. What can I tell you about RDS? It offers MySQL, it offers MariaDB server. It has a obviously a more limited feature set, so you don't get to use the MySQL 8x protocol, MySQL SH. With MariaDB server, you don't get the encryption. Of course, MySQL's encryption is also not there. Yeah, the engines. It is however fully managed for you. It does have an automatic upgrade window, which we talked about, and how it can also totally affect you in terms of degraded performance via increased I/O latency. However, it also has everything done easily within a GUI. So you largely really trade off control of the database for ease of use and management. Aurora is a little bit of a different beast. Aurora MySQL. Aurora, as I already said much earlier, doesn't even use MySQL replication in any way, shape, or form. Basically, each 10 gigabyte chunk of your database volume is replicated 6 ways via physical replication across 3 availability zones. It also uses a quorum for writes, where it writes to 4 out of 6 nodes that are available to you to increase write performance. Um, it obviously is self-healing. It has instant recovery because it uses parallel distributed asynchronous redo logs. It has zero downtime migrations from RDS. Metrics, of course, via CloudWatch. It does promise fairly high uptime. You don't have to worry about the cache generally because it's warm across database restarts. You decouple the cache from the database process. You can have 2 versions of it, the 5, 6, 10 fork, which has no optimizer, and you can use Aurora to MySQL replication, obviously. And then there's also the 5.7 fork with JSON support, spatial indexes, generated columns, and so forth. So I guess it's very important to remember that these are really forks. They're not really MySQL. You speak a lot of MySQL, but they're not MySQL underneath it. It obviously does autoscale for compute memory storage. And you can also have up to 15 read replicas for scaling reads horizontally. Any read replica, of course, can be promoted to being a database master fairly quickly. And you can also have off-volume snapshots to S3 via backups with no load on the database. You do encryption with the key server being Amazon's KMS. For what it's worth, Galera can also do encryption with external key servers. With MariaDB, you can use the Amazon KMS. With Percona, you can use Vault. Vault will also work with Galera's Galera cluster with MySQL. It's also obviously spatial data support. Basically, this came through InnoDB 5.7. And there's also a lab mode where you can actually turn on things like hash joins, scan batching. But Aurora is not just like a fork, right? It does have some interesting things. Because you're throwing away the replication layer, you're throwing away the optimizer. You have to ask, what do you get out of this? And I don't know if you're familiar with serverless functions. Amazon has a service called Lambda, where you write functions as a service, and then you call functions, and you spin up these little instances. They run, and then they shut down, and they're fairly cost effective. And RDS Aurora MySQL has serverless function support, which is kind of cool. It can also do parallel query, which no MySQL actually has at the moment, or no MySQL variant. It'll eventually probably come, but it's not there yet. Just have to remember that not all the features you're used to 5.6 and 5.7 exist inside of RDS Aurora. So that's clearly something to think about. I don't like to personally go and diss any products, but if you'd like to go check out a blog post about 4 things you didn't know about Amazon Aurora, feel free to click on that link. It talks about the fact that it's an aging, outdated database. It's a fork of much older versions of MySQL. Then it's some things about downtime interruption, the enterprise security, and the least common denominator basically states the fact that it has the basic features you need of MySQL, but not the more advanced stuff that you may find interesting. So it all comes down to underlying replication types. So with RDS, MySQL, and MariaDB server, you are using DRBD. This is Linux-based block replication. It's like RAID over Ethernet. It is slower compared to any replication that MySQL has. With RDS Aurora using physical replication, yes, this is fast, but this is also something you cannot migrate off Amazon. There is just no Aurora alternative in the open source world, and I think this is kind of an issue because today it may be cheaper, but what happens if tomorrow it's not, and what happens if you want a feature that's not available, and so forth. The roll your own Galera cluster option with virtually synchronous replication. This is basically built in MySQL replication. This is also there for you to use. If you don't like running in EC2, you can move it to Google Cloud SQL. If you don't like it there, you can move it to Azure instances. If you don't like either of these clouds, you can go to Alibaba Cloud. You can go to on-prem. It's much more convenient. Google Cloud SQL, for what it's worth, does use semi-synchronous replication. They don't actually use DRBD or any kind of other weird replication that's available. And I've not really seen any automated services with asynchronous replication because I think it's too hard to do automatic failover and ensure that no data got lost. Because the last thing you want to be as a managed service is saying things like, "Hey, I've lost your data," and then invoke some support people. The best way, in my opinion, for you to generate cost information is to check out the Amazon cost calculator. They actually have a nice little app that can help you, and you can actually input things like network and so forth. And we also have a 1-hour tutorial in our Galera cluster library on how you can set up Galera on AWS, and it's done by a person who does documentation for us, Russell Dyer. It literally is 1 hour. It's fairly interesting. It's true that he tells you to install things like rsync, and he does make use uh, of CentOS instead of Amazon Linux. But yes, typically if you're going to use Yum, it should pull in rsync generally. But it's obviously a little bit more detailed and things that you may or may not need. Largely because it's better to be more verbose if it's just the tutorial of running Galera cluster on AWS. Anyway, there are obviously things that we probably should think about in the future. Like, I don't know how many of you would be interested in AWS Marketplace image to roll this out easier so that you don't have to do all these stuff manually like I just did. So a marketplace image would basically, automatically provision security groups accurately, ensure the my.cnf is accurate, and so forth. So that could be like so much easier for most people. But the question is, would you pay for something like that? How many of you would like Kubernetes support? So you can roll out Galera cluster inside of a Kubernetes instance. I don't know what else you'd like. And you can feel free to share with us what else you'd like. Some people also ask about benchmarks, like can you do a benchmark of RDS versus Multi AZ versus Aurora versus rolling out Galera cluster? And we're not quite in the business of doing benchmarks, but that's something that we would definitely want to do if we have the cycles to do. So we may actually end up doing that at some stage. And if it's important to you, please reach out to your sales rep and tell them that is something you'd like. Yeah. And with that, I'm gonna actually open this up to questions. And for this version, I can actually read the questions. So I'm going to answer some questions. These slides will be obviously available as well as a recording. So Sakari will send out all of that probably in the next day or so. So I'm going to answer some questions that have been posed in the question box. How does it compare to Veritas cluster? Frankly, I cannot give you an answer to that. We have to definitely do that offline. So we don't really look at Veritas cluster. In talks, I'd say Galera is more like, it can be like an Oracle rack replacement to some extent without having the expense of a SAN, which is quite nice. So this is only with InnoDB. Yes, this is currently basically InnoDB only. At some stage maybe there would be other engines beyond InnoDB, but for what it's worth, DRBD is also more or less InnoDB only. EC2 instance running a MySQL slave from the Galera cluster as a master. So I guess the question is more, also have a Galera cluster, have another EC2 instance running an asynchronous replica? And the answer is, of course, yes, Galera does work with asynchronous replication as well. Okay, so the refresh rate of the screen of the demo, I'm sorry, can't slow down the demo any longer, but if you need a more slower demo, please check out that video that I linked to earlier. Give a good sample of running Galera cluster with MariaDB AWS key management plugin. We obviously don't have a is available, but you can go and look at the MariaDB documentation, and there is actually how you run Galera cluster with encryption and using the AWS key management plugin to manage your keys. Of course, if this is also something that we could, probably help you with. Again, feel free to speak to someone else, someone in sales. Though I guess we can't really sell MariaDB. And yeah, okay. So those were all the questions. Um, Zakaria, do you have anything else?
No, I'm fine. I'm fine. I hope everybody joined our webinar. And as said, we are going to do a email of the recording, so you get the recording as well.
Okay, so thank you for listening, everybody. Thank you for your time.
Yes, thank you. Bye-bye, and see you next time.